In the hyper-advanced landscape of 2026, the singular reliance on isolated large language models has become a strategic liability for every modern enterprise. We are witnessing a fundamental shift where autonomous agents no longer operate in vacuums but collaborate within sophisticated and highly resilient consensus networks. The persistent challenge of stochastic hallucinations continues to plague frontier model deployments, requiring a paradigm shift toward multi-agent architectural verification and review. Organizations across the globe are now prioritizing the elimination of generative errors through structured peer review protocols designed to ensure absolute data integrity. We must move beyond simple prompting into the realm of adversarial agentic collaboration, where truth is negotiated through rigorous and systematic computational debate. The convergence of reasoning agents and automated auditing frameworks represents the next frontier in the quest for truly dependable and trustworthy artificial intelligence. Technical leaders are rapidly adopting multi-agent consensus mechanisms to safeguard mission-critical workflows against the inherent unpredictability of modern deep learning model outputs. By leveraging the collective intelligence of specialized sub-agents, we can effectively neutralize the risks of misinformation while maximizing the utility of generative systems. Today, we will deconstruct the sophisticated architecture of multi-agent debate models and explore how they provide a definitive solution to persistent model hallucinations. You will learn how to implement robust validation layers that reduce error rates to negligible levels while significantly enhancing the reasoning capabilities of systems. Our objective is to provide you with a comprehensive technical framework for deploying agent-led peer review systems that scale across diverse industrial applications. By the end of this deep dive, you will possess the strategic roadmap necessary to architect high-reliability AI environments using advanced Python-based consensus frameworks. Current research from the Vector Institute and Hugging Face suggests that model performance peaks when agents are subjected to peer-level scrutiny and feedback. The transition from monolithic AI entities to modular agentic swarms is driven by the urgent need for transparency and accountability in automated decision-making. According to the NIST AI Risk Management Framework, the integration of cross-validation protocols is essential for managing the systemic risks of frontier AI models. European standards for trustworthy AI now emphasize the importance of human-in-the-loop and agent-in-the-loop architectures to ensure high-stakes accuracy and operational safety. As we push toward the singularity, the ability of machines to verify their own logic becomes the primary differentiator between experimental tools and enterprise assets. Digital transformation strategies are increasingly reliant on these self-correcting systems to maintain a competitive edge in an era of rapid technological disruption. We see a growing trend in the Global South where sovereign AI models are being trained with built-in consensus mechanisms to protect cultural data. The technical complexity of 2026 requires us to rethink how we validate information in real time across distributed networks of specialized and autonomous agents. Industry leaders like Microsoft and OpenAI are already implementing multi-step verification pipelines to refine the outputs of their most advanced generative engine models. The following strategic pillars will guide you through the implementation of these critical consensus architectures for your specific enterprise or research project needs. Architecting debate models involves creating a dynamic environment where multiple agents are assigned distinct roles to scrutinize and verify each other's generated outputs. This adversarial setup forces agents to justify their reasoning through evidence-based arguments, effectively surfacing any underlying hallucinations or logical inconsistencies within the system. By implementing a proposer and critic agent structure, you create a continuous feedback loop that refines the initial response into a verified conclusion. These debate models utilize specialized reward functions to incentivize agents to find flaws in opposing arguments, ensuring a rigorous and comprehensive review process. The result is a more robust and defensible output that has been pressure tested by multiple independent perspectives before reaching the final end-user interface. Reducing error rates to less than 1% is achievable when cross-agent validation protocols are applied to every step of the generation process. Data from recent open-source benchmarks shows that consensus-based systems consistently outperform single-model architectures in complex reasoning tasks and factual accuracy measurements. The core of this reduction strategy lies in the mathematical probability that multiple independent agents are unlikely to hallucinate the exact same misinformation. We achieve this high-fidelity precision by requiring at least 3 agents to reach a consensus on any factual claim before it is finalized. This threshold-based validation acts as a powerful filter for noise and errors, providing the reliability needed for applications in finance, healthcare, and law. The role of the judge agent is critical in final decision auditing, as it serves as the ultimate arbiter of the debated information. This specialized agent is trained to evaluate the strength of evidence provided by the debating agents rather than generating its own original content. The judge agent applies strict logic and adherence to the provided context to determine which agentic perspective is most accurate and most reliable. By separating the roles of generation and auditing, you create a system of checks and balances that mimics professional human-led peer review processes. This auditing layer provides a clear and transparent trail of reasoning, which is essential for compliance with global AI governance and safety regulations. Implementation of these systems is streamlined through modern Python frameworks specifically designed for agent orchestration and multi-agent communication and peer review. Frameworks like LangGraph and CRY allow developers to define complex interaction patterns and consensus logic with minimal code and maximum flexibility for scaling. These tools enable the rapid prototyping of agent-led review systems that can be integrated into existing enterprise stacks with high efficiency and security. Python-led peer review systems provide the technical agility needed to adapt to the evolving landscape of frontier models and changing business requirements in 2026. By mastering these frameworks, you can build self-healing AI systems that continuously improve their own performance through internal collaborative learning and peer feedback. Consider an enterprise scenario where a multi-agent system is tasked with summarizing complex legal documents for a global manufacturing supply chain transformation project. The first agent generates an initial summary, while the second agent acts as a skeptical critic, identifying potential misinterpretations of the contractual clauses. A third agent researches external case law to provide context, while the judge agent reviews all inputs to ensure the final summary is accurate. This collaborative process ensures that any hallucinated legal advice is caught and corrected before it can impact the organization's strategic decision-making process. By applying this debate model, we observe the error rate drop from 15% to well under the targeted 1% precision mark. The judge agent provides a detailed audit log explaining why certain corrections were made, offering full transparency to the human legal team overseeing the system. The Python framework orchestrates the communication between these agents, ensuring that the entire review process takes place in a matter of mere seconds. This real-world application demonstrates how consensus-based architectures transform generative AI from a creative tool into a dependable, high-stakes enterprise information system. Companies adopting this approach report significant improvements in operational resilience and a reduction in the costs associated with manual data verification and auditing. The synergy of specialized agents and automated auditing creates a virtuous cycle of accuracy that is essential for the future of digital economy strategies. We have explored the critical importance of multi-agent consensus in eliminating hallucinations and building trust in our increasingly autonomous artificial intelligence systems. The transition to debate models and independent auditing agents represents a mature and necessary evolution for the global technology and cybersecurity landscape of 2026. Strategic leaders must now prioritize the deployment of these self-correcting frameworks to ensure that their AI investments deliver maximum value and minimal risk. The future of AI is not found in a single perfect model but in the collaborative intelligence of many specialized agents working in concert. As we continue to push the boundaries of AGI, we must remain committed to the principles of transparency, accountability, and technical excellence in engineering. Stay ahead of the innovation curve by exploring our deep dive resources on agentic workflows and sovereign AI developments at the AI Knowledge is Power channel. Connect with our global community of researchers and technologists to share insights and best practices for building a more secure and intelligent future. Turn knowledge into your greatest asset by applying these strategic frameworks today and lead the global innovation era. Join the vanguard of AGI development by mastering agentic consensus protocols today and secure your position in the 2026 digital economy. Channel powered by generative AI architecture.